Assalamu alaikum dear students. Welcome to my YouTube channel Math Experts. Students, please do subscribe my YouTube channel, click the bell icon, and if you have any question related to these topics, you can send me via email, and in comment section I will solve these questions and send you a link. Students, if you are interested uh, in any suggestion related to giving me any suggestion related to my YouTube channel, you can send me via email. Email is given in the description, also in the comment section. Today, our topic is related to the Laplace transform, and first we Laplace transform of integrals. Laplace transform of integrals. So here we can study about how we can find the Laplace transforms of integrals. As you Laplace transform is basically an integral transform, and how we can apply the integral on the Laplace transform. As you know that we previously studied how to find the Laplace transform of derivatives, how to form the Laplace transform of two functions and initial value problems and their Laplace transform. And today we study most important topic in this regard. First of all, we discuss the convolution theorem. What is a convolution? We discuss this thing. Convolution. Convolution, if we have two functions, I will write first definition. If function f and g are piecewise continuous, on the interval 0 to infinity, and then a special product denoted by how we can denote this? F steric G. F steric G is defined by integral F steric G is equal to 0 to t, the limit f of the g of t minus tau, and then d tau. Okay, and is called convolution of f and g. So student, here you can see that we have defined the convolution of two function. For example, I have two function, one is f and the second one is g. So when I defined the convolution on this interval 0 to infinity, the special product is defined in this form. So this is basically the definition of convolution when we want to find the convolution of two functions f and g, both are piecewise continuous. And one important thing I want to mention here is if I want to find the convolution of f steric g, which is equal to g steric f, so it's mean that convolution is basically holds the commutative law. Now we if I want to find the Laplace transform of these two inter functions, like I have f and g function, and I want to find the Laplace transform of these, so we will prove the convolution theorem. Convolution theorem. We will start here. If f of t and g of t are piecewise continuous, piecewise continuous on 0 to infinity and of exponential order, because we are finding Laplace transform, so by using convolution, so it's mean that uh, function are piecewise continuous on this interval, and the second condition is and of exponential order. Exponential order. Then Laplace of f steric g is equal to Laplace of f of t, Laplace of g of t, and you know that the Laplace of f of t is equal to f of s, and Laplace of g of t is equal to g of s. So we need to prove this thing when we apply the Laplace transform on these two functions which are piecewise continuous, and the second thing is both are continuous on this interval, and the second thing is both are of exponential order. So we have to find the Laplace transform of these in this way. Now student, we will prove this theorem. Proof. First of all, you know that f of s is Laplace transform of f of t, and if I write in the definition form, which is equal to 0 to infinity e raised to power minus s of tau, f of tau, and d tau. Okay, and I call this equation number 1. Similarly, if I have g of s, and you know that this is the Laplace transform of g of t, okay, and by definition 0 to infinity e raised to power minus s of beta, f of beta, or d beta, which is equation 2. I just, beta is here dummy variable, we can change this. You can say x or tau 1, just like anything. Now, the product f of s g of s. Product f of s g of s is similarly the product of these two. The product of 0 to infinity e raised to power minus s of tau, f of tau, and d tau. Okay, and product of this function 0 to infinity e raised to power minus s of beta, f of beta, d of beta. Okay students, now we multiplied these two integral, and what is the next our relation we can find this. Okay, so we multiplied f of s and g of s, which is equal to integral 0 to infinity e raised to power minus s of tau, f of tau, d tau, okay, and 0 to infinity e raised to power minus s of beta, f of beta, d beta. So I can multiply these two, we get 0 to infinity, and then again 0 to infinity, the second integral, which is 0 to infinity e raised to power minus s of tau, e raised to power minus s of beta, f of tau, f of beta, then I have eta, and then I have d of beta. Okay, now I can write this in this form: 0 to infinity, again 0 to infinity, e raised to power minus s of tau plus beta, tau plus beta, f of tau, f of beta, beta, and d beta. Okay, students. Now let here, if I choose, let I choose tau plus beta is equal to t. So it's mean dt is equal to, and I differentiate with respect to the beta, and I get d of beta. Okay, it's mean beta is equal to t minus tau. The first thing, dt is equal to d of beta. It's mean I want to change this d of beta with d of t. So the d of beta has limit 0 to infinity. It's mean when beta is equal to, when beta is equal to 0, t is equal to tau. When beta is equal to, when beta is equal to infinity, when beta is equal to infinity, then t is equal to infinity plus t is equal to infinity plus tau, which is equal to infinity. So in the case of t, our limit will approach from tau to infinity. Now in next step we get f of s, g of s, which is equal to integral 0 to infinity, integral 0 to infinity, e raised to power minus s into t minus s into, sorry, tau plus beta. We have tau plus beta. Then I have f of tau. I have f of tau, g of beta. Okay, g of beta, theta, and d beta. Okay, now replace here this the value 0 to infinity. Then our integral will change. The limit will be tau to beta. You know that in previous step we find the limits. This limit from tau to infinity. Tau to, sorry, not beta, tau to infinity. Okay, tau to infinity. Tau to infinity. Then we have e raised to power minus tau plus beta. Tau plus beta is equal to t. So we have e raised to power minus s of t. Okay, I put here t. Then I have f of tau, g of, and then I have to change this beta with, beta is equal to t minus tau, which is equal to t minus tau. Okay, and then I have theta and dt. Okay, I get this type of integral, which is equal to f of s and g of s. Now students, be carefully. We want to change the order of integration. For the order of integration, for changing the order of integration, I will tell you here. If I have this one axis, which is called, and this axis, so we label these axes with this and this. This is our t axis, and this is our tau axis. Okay, so now we have here theta and dt. Okay, and we want to change this with dt and theta. Okay, students. For this, we have theta and d beta, theta and d beta. So I want to change this with dt and d tau. So for this, if I change the order of integration, sorry, I want to change here the order of integration. I want to change the order of integration. So here, if I take like this, I am taking here integration in this sense. In this sense, like I am taking integration like this. This one, in this order, I am taking integration from here to here. This is the order of integration first. And here in this case, the limit is from here we have t is equal to tau. This line is equal to t is equal to tau. And here we have limit from tau to infinity, goes to infinity. Now I change order here. This order will be reversed. So I draw again axis like we have here, and the second axis t axis, which is equal to our t axis, which is equal to our tau axis, and here we have this one. Now if I change the order of integration in this sense, like I am integrating like this, like this, like this, like this, and like this. Here you can see that we have integration from 0 to t, where t is equal to tau. Okay, students. Now it's mean that our integration is completely changed. So our order of integration is completely changed. Now this limit will be changed. So this limit is equal to f of s, g of s is equal to integral 0 to infinity. And now first we have limit from tau to infinity. Then we have limit from 0 to t, 0 to t e raised to power minus s of t, okay, f of tau, g of t minus tau, theta, and then dt. Okay, now if you know that here we are integrating with respect to the theta, so e raised to power minus s of t is a constant, so I can write here f of s, g of s is equal to integral 0 to infinity, then e raised to power minus s of t is constant with respect to the theta, so where you come back minus s of t, then I put here 0 to t, f of tau, g of t minus tau, next we have theta, and then we have dt. So you can say that here, if I put here the brackets like this is the convolution of two integrals. Okay, this is the convolution of two integrals. Now I can write here 0 to infinity e raised to power minus s of t, and then bracket 0 to t, f of tau, g of t minus tau, and theta, and then I have at end dt. Okay, and this is called the Laplace transform of f steric g, because in the place of f of t, because this is our this whole is our f steric g. So this is the Laplace transform of two functions which are piecewise continuous, which is equal to Laplace of f steric g. I hope you can understand this. If you have any question, please don't hesitate. You can ask in our comment section. You can ask us through email. We will solve this and send to you. Thank you.